there we go. It is unmuted now. Sorry about that. All right. So even though every file is only 96 bytes, as you have discovered in Lab 6, it will still consume an entire block. So even though it's small, it still consumes a block. So each file will consume one block, and then a file is represented by an inode. So each file will need 128 bytes for the inode plus 4,096 bytes for the block. So that is how many bytes I need per file, which is 4,224. And then since I have 1,000 files, it's just that number times 1,000. So in total, I need, well, that many bytes to store all of the files, even though they consume a lot less.
Not like overthink this and say, oh, but you also need something for the bitmaps.
So you need something for the bitmaps if you really want to. If you want to go into like deep thought, I guess, but
My brain would go to there.
but then you don't know if all the inodes are contiguous and so on and so forth. So you could do that as long as it seems like you know what you're doing and you have these two numbers included, then probably fine. All right, so as for the previous question, how many bytes are lost due to internal fragmentation? You may say 0 bytes if that is the case. So how much space are we wasting to internal fragmentation?
4,000 bytes each? Yeah.
Yeah, so for each file, well, each file gets a whole block, which is 4,096, but it only uses 96 bytes of that. So if I subtract 96, that means I have lost 4,000 bytes due to internal fragmentation per file. And if I have 1,000 files, well, I multiply that by 1,000, which means I lose 4 million bytes due to internal fragmentation. Yep.
Is there no way for blocks to be shared, like it's not a thing, like it's not computation that entire thing?
No, so each of them, they will not share a block because, well, they'll be mapped to a page in memory at some point eventually, whenever it wants to read it in. And then you might get in the case where, well, if they're sharing a block, well, you can only read one block into memory, so you can actually read the contents of another file, even if you don't have access to it, because you're just reading a block. So they all need to be on separate blocks. All right, so question 4 came up, and this is how I came up with this question. It's because I started copying files, and you know, like in Windows Explorer, it'll show you how fast the progress is going. And then I hit a bunch of small files, and then I just saw the progress and I was like, oh, students in the course could explain this now, especially if I set it up like this. So question says, why might copying a directory containing a single large file be faster than copying a directory with many small files, even if the total size of the small files is less than the size of the large file?
Because for each file, we have to copy a page and...
Yeah. Yeah, so if I have a single large file, what do I actually have to copy? Well, I have to copy one inode, which is pretty small, and then I have to copy, I don't know, say it fills almost like 1,000 blocks. Well, then I copy one inode and then 1,000 blocks. And since it's one large file, well, the last block might have a bit of internal fragmentation, but overall it'll probably be negligible. So I essentially have 0 fragmentation because it's all one big file. Well, if I just have, I don't know, say, let's say I have even more. Let's say I have 5,000 small files. Well, that's 5,000 inodes plus 5,000 blocks, even if each file only uses like 1 or 2 bytes of the block. But it's still going to need to copy over the entire block, and it won't count towards the progress of copying a file because like Windows will only tell you how fast it is at actually copying the contents of the file, not anything else associated with it. So in this case, the size of the inode could be bigger than the actual contents of the file you actually care about. So it might actually spend most of its time copying the inodes and taking more time doing that and just having more blocks, even though that this might only use like, 5,000 bytes in total across all the files, because each file needs an inode and each one of them also need a block. It's going to be really, really slow. So questions about that?
Does that mean that my computer can actually only store when small files and maybe just do this just because each one is just
Yeah, so disk usage, well, depending on however you report it, sometimes operating systems will lie to you and say files consume a block whenever you look at like disk usage, even though it's not technically true, but they're consuming blocks. So it depends on the file systems and whatever your operating system wants to tell you. So likely it'll just tell you it's full and kind of hide details for you. But yes, you'll run out of space much faster if you have a bunch of small files. So you run out of space before you expect. All right, so any other questions about that part? All right, so next one. Assume an inode has 12 direct blocks and one, I guess this should be clarified, one single indirect block. Whoops, that word should be moved up. Come on. One single indirect block. What is the maximum file size in kilobytes that can be supported? You may skip the final calculation if you don't have a calculator or you forgot it or whatever. So we'll go back up, so I will copy the relevant information. So my page size, or block size, I guess I should say in this context, is equal to 2 to the 12. And then my pointer size was equal to 4 bytes or 2 to the 2. So what is the maximum size of the file I can support if I have 12 direct blocks and then one single indirect block? Yeah. So, well, through the 12 direct blocks, well, I could point to 12 blocks and they're 4 kilobytes each. So through just the direct pointers, I could store up to, was that 48 kilobytes? But through the indirect block, that's probably where most of my pointers are. So assuming that I have no other metadata, I need to figure out how many pointers I can fit on a block. So that's just block size divided by pointer size. Whoops, that was the wrong tool. So it's just block size divided by pointer size, which means I can fit 2 to the 10 pointers on a block. So using that single indirect block, I can point up to 2 to the 10 more things. So in total, I can point to 12 blocks through the direct pointers, plus another 2 to the 10, which is 1024. And then each of them points to a 4 kilobyte block, so I could just multiply that by 4. So in that case, it's what, 136 times 4, which is 4,144 kilobytes is the maximum size of the file with this kind of scuffed inode. Yeah.
This 2 to the 2 possible pointers, like there's not actually that many distinct blocks.
Sorry?
Point to
2 to the 10 different things.
so
So the pointer size, they're only 4 byte pointers.
oh, 4 byte.
4 byte pointers, yeah, not 4 bit.
4 bit.
Yeah, no, 4 byte pointers. Yeah, 4 bit, we would be in trouble. All right, questions about that? Yeah.
So indirect blocks are pointers to blocks.
Yeah, indirect blocks is like one page table. Same concept.
And why can't we make an inode support like both direct and indirect blocks at the same time?
Sorry?
Like
Single indirect block is the CFU block.
Yeah, it's just by definition. So if you look at the spec, especially in your lab 6, use an inode. So the first 12 pointers are all direct, and then according to the spec, index 12 is the single indirect, and then the next one is double, and then the next one is triple. So you just have to read the spec to know what to do. That's real computing in a nutshell. And then you read the spec, and then it's wrong, and then you work around it, and then you're pod racing. All right, so next question is, how many directories, wait, all right, this is already too late. How many directories need to be accessed when attempting to read a file located in this path? Home user uToronto ECE 353 labs grade.txt. Assume that grade is a regular file. So how many directories do I need to go through? I have 1, 5. Should be 5. So what's the first directory? Always? Slash. What's the special name for slash? The root directory. So here it would be 5, so I have to start at the root directory, which would be slash, and the only reason we know how to start there is it just gets a special inode number. It's inode 2, and that is how we know where to start with a file system. So we start at the root directory. Inside there would be the home directory, so we would access home. Then inside home would be user. Then inside user would be uToronto. Then inside uToronto would be ECE 353. And then this is just a regular file. So in total, we would access 5 directories because, well, it starts at the root directory. All right, next question is even more fun. So you think you should create a copy on write file system, but someone who hasn't taken this class says you don't need to because you can already do the same thing with hard links. Explain to your friend why they are wrong. What are the differences between file 1 and file 2 being hard links to the same inode, and the concept of copy on write? Can I achieve copy on write using hard links?
what's a hard link?
Like, hard link is just
So hard link is node to inode.
so the first thing is hard link is not copy on write because they're pointing to the same physical block on the disk.
Yeah,
Right?
so if they are hard links, then file 1 and file 2 are actually pointing to the same inode, and then that tells us where to go to get all the contents. So if I try to modify file 1 and I save some changes and I try to access file 2, I'm going to get those changes in file 2. They're not going to be completely independent, which is what I want from copy on write. I want them to be independent, but I also want them to share blocks if they can. But as soon as they differ and one tries to write, then I have to make an independent copy and make sure that, well, through both of the files, they are both independent. So, answer to this is no. If they are hard links, if I change one, I change the other. With copy on write, I want the 2 files to look like they are independent, even though they are actually maybe sharing information. And I cannot achieve copy on write using hard links because, well, they just refer to the same inode, same contents. There's no way to actually share it. So some file systems are copy on write file systems, but it's not achieved through using hard links. It would essentially need to do what you do in like lab 3. So you need to keep track of what pages are being shared. And if you modify them, then you create a new copy, update whatever one changed it, so on and so forth. Same concept.
But it's not what I'm asking. Like right now, file 1, file 2 are both hard link, inode 1. And then if you're reading, as long as you're reading, you're fine. And then as soon as you write, you have one of the files points to the inode.
Yeah, if I'm reading, well, essentially, well, there's the same inode, it's the same contents. So it's not like they're even really sharing pages anyways. You're just referring to the same thing.
Therefore, the copy on write part, if now you're trying to write to
But if they're hard links, then if you modify one, the other one gets modified.
Like, hard link doesn't depend on the icon. Like, if you like the one, just modify different icon. You're not like actually.
You can't point your inode.
Hard links
No.
two inodes pointing to the same block.
Yeah, so can you point one away?
What do you mean? So they're both pointing to the same inode.
Yeah, so
Yeah.
they are. So why can't you point one away?
Yeah, you could point one away, but it says, can you achieve it just using hard links only?
Well,
As long as
how
you're allowed
are
to
you
use
not
one.
You would need file system level support.
Yeah, you need files, because if you make them independent, that they both point to a different inode,
Yeah.
now they're independent, but now they're not sharing data. They're not sharing a,
Copy of right part, like I'm not supposed to share after the write.
but here they won't be sharing anything at all. This would point to like block 12, this would point to block 13 or something like that.
So this would happen after you try to write, after you trigger a write.
That's if we implemented a copyright.
Okay, I'm not understanding much. To me, it seems like
So this is like, I want to implement a copy on write file system without changing any of the details of the file system, just using regular old hard links. Can I implement it?
Look,
based on how I interpret that question, repointing it, repointing file one to point a different inode is still using hard links.
But you're pointing it to a different inode, but you're not sharing blocks or anything.
I think what he's talking about is trying to say that like his approach is copy on write.
Yeah, you're basically saying, I make them point to different inodes and I implement copy on write. Therefore, I can implement copy on write.
Okay, so I'm just
Yeah, you could do it, but not just through inodes. So we got that.
I think that particular question was not exactly clear. Like,
yeah,
this is like a fusion, right?
Yeah.
I don't think you could legitimately say that I could implement copy on write in a way that makes use of the existing hard link.
Yeah, if you just explain copy on write and you do it and like explain how you do it, that's fine. Because yeah, it can be interpreted in some different ways. So this one was loosely marked. If you actually told me how to implement copy on write using that, as long as you said same things, that's fine. You'll be fine. All right. So should we do this threading question? Or carry on to something else?
Are there, can we see the other questions?
Yeah, do we want to skip through some questions quick?
Can we just see what else is good?
So we got a threading question. Then we have a lock question. So carry on, all right. Then we have a locking question, which has center-fors.
Should we do this?
Well, let's skip. And then we have a memory allocation question, which is,
The last two.
Let's do this afterwards.
and then we have a disk question
Let's do this one.
that talks about RAID, and we have a file system question, again. And then we have a virtual machine question, which is not going to be relevant to you. So which one do we want to do?
Let's do disks and file systems.
Disk and file systems? So yeah, let's swap over to disks. All right.
This is really straightforward,
Well,
RAID is
so inspired by the course and your data hoarding, you decide to build yourself a RAID. You buy yourself 8 hard drives. They're 4 terabytes each. What RAID configuration would you use if you really, so there's 2 reallys here, so that's a clue. Really care about your data, justify your answer.
not really show the answer, but
Basically, the one that keeps 2 separate copies in each of
Yeah.
the.
2 separate copies, but RAID,
one will, but do we have to use RAID 1? We don't know how much data.
Yeah, that's what I meant. Yeah.
so RAID 1 is really care. So RAID 1 is you make an exact copy of every disk. So in this case, if I have 8 hard drives, I can tolerate 7 of them failing before I lose any data.
Can RAID 1 have more than two drives? Can it just be one copy?
Sorry?
Can we have multiple copies of RAID 1? I thought it's just 2 copies.
So,
I think we have more.
so RAID 1 is just, every disk is exactly the same as one
I thought
another.
it's just 2 systems mirroring each other.
No, it's a mirror of every single disk.
They're RAID 1.
So RAID 1 is a mirror of every single disk. For some reason in the O-step book, they call RAID 1 RAID 10, but RAID 10 is actually a combination of RAID 0 and RAID 1. Why they do that, I don't know. All right, next one is, what RAID configuration would you use if you care about your data but want more than 4 terabytes of total capacity? So RAID 4 is one we should always avoid because it is silly. Anyone remember why RAID 4 is silly? So, yeah, RAID 4 and RAID 5 are both the XOR one, so essentially one disk is used for parity, but in RAID 5 or RAID 4 we have a dedicated parity disk, so it comes a bottleneck, and RAID 5 is the same idea except that parity is distributed over the rest of the disks, so we don't have a bottleneck. So RAID 5 is just a strictly better version of RAID 4. So in this case,
We use RAID 5.
we want RAID 5. So if we have RAID 5, how much total capacity can I use?
8 hard drives. If you have
3.5
7 or 28 terabytes.
28 terabytes?
yeah, if we use 1 terabyte.
I think we need to use one drive for XORs and the rest we can store data.
Yeah.
Exactly using 1
the
terabyte.
Yeah, essentially we use the capacity of one drive for parity information. So we waste one drive, so our total usable capacity is 7 times 4. So if my math is correct, that equals 28 terabytes. So I can use 28 terabytes of usable space, and I can tolerate one disk from failing. So one disk fails, no problem. I can chuck in another one and rebuild it. So yeah, that is good, justified. So what RAID configuration would you use if you only care about performance? Justify your answer. State how much faster your read and write performance would be compared to a single disk.
0.
RAID 0. What's RAID 0? You just stripe that data across all the drives, and how many times more than a single disk am I going to improve my read and write performance with RAID 0?
8 times.
8 times, yeah, so I'll get 8 times better performance, but if a single drive dies, I am now screwed. So, you get to benefit from all 32 terabytes of storage, but, 8 times read and write performance, but if one fails, you are now screwed. So, live fast, die hard. All right, cool.
That's it.
Yep, that's it. So, next one, do we want to do this file system question?
Let's do one more.
All right, one more quick, that only took 5 minutes. So you'll be using your knowledge of file systems to explain the differences between LN and CP in terms of inodes and blocks. Assume you have a file called myfile that contains 2090 bytes. The block size of the file system is 4096, so it fits on a single block. As a hint, I ran the ln and cp commands, and you'll find the output of ls after this. So here, I created ln with just no extra arguments. This creates a hard link, remember? So my file and ln should be pointing to the same inode, which I can see that they do. It's inode 101 for both of these. And then I see if I CP it, whoa, they don't point to the same inode, they get a different inode. It gets inode 102. So first question says, explain what happens on the file system when you run the ln command. Start your explanation with a new directory entry for ln-file.txt.
We create a copy of my file and name it ln file, and then we make the inode point to, we make the inode 101 point to both my file and ln file.
So
That's an interesting way
Wait.
of expressing exactly the
yeah, so inode 101 does not point to anything. Hard links is name pointing to an inode.
Yeah, you create a directory entry called ln-file.txt, and you make it point to inode number 1, which is just inode number 1.
So we have a new directory entry for something called lnfile.txt. Then we probably have to, well, if you want to go into excruciating detail, we have to look at the entry for my file, see what inode it refers to, and then in this new entry, we make lnfile also refer to inode 101. So lnfile.txt, that points to inode 101, and so does myfile.txt, it points to inode 101, so they are both hard links. So current directory, we make a new entry for ln.txt. It would be assigned the same inode as my file. On the inode itself, it would also increment that link count by 1, which I didn't explicitly ask for in this question. So if you said that, I was happy. There was no bonus marks for it, unfortunately, but it would increase the number of links to that inode as well if you really wanted to be super explicit about it.
So inode doesn't point to files, but the other way around.
Yes.
Huh.
Name points to inode.
File names in a directory entry from file names are not associated with the data themselves, except through the directory that contains the file.
Yep. All right, so next one. Explain what happens in the file system if you run the cp command. Start your explanation with a new directory entry for cpfile.txt.
You first, you do have to make a copy to the block.
Yes. Sorry? Yeah.
We get a new block and then we copy everything.
On the disk, and then we make a copy of the inode and point it to the new block, and then we make a new directory entry called cpfile.txt and we point it to the new inode.
Yeah, so first thing I would do,
Wait, what
Is-
does inode point to again?
inode points to the contents of the file, has all the metadata about it, who owns it, when it was modified, all that fun
So
stuff.
file names and file contents are two different things.
Yep.
Oh, I never knew that.
All right, so first one, I create a new directory entry for cpfile.txt, and then, well, next thing I need to do is I need to grab a new inode because I'm creating a new file that's just, it's essentially kind of like fork. It's supposed to be the exact copy of whatever that I am trying to copy from. So I grab some new inode. In this case, it was obviously 102. And then using that inode, well, I would copy the data from inode 101 and make 102 an exact copy of that. And then, well, it points to a block. So I would have to, in step 2, grab a new block. Then I would need to, on step 3, actually byte for byte copy the contents of my files block 0. Copy my file block 0 to cp file block 0. Make inode 102 point to that content, and then I'm done. Now they are two separate copies that are independent but look exactly the same in terms of content.
Would you be opposed if, like, last all this question I said, oh, the inode gets a deep copy and then CP gets pointed to the inode?
The inode gets a deep copy? Sure. Sure.
Like, that's few verbose.
Yeah, too many words, so this was really wordy, but yeah, if you say it gets a copy of everything such that it's independent, or a deep copy, it implies that, that's fine. All right, so that was 6 minutes. All right, which other question do we want to do?
Let's start from the locks.
Locks?
One with semaphores.
This lock one?
The one with the semaphores.
The one with the center fours. This one?
Yeah.
There's locks and locking. That's pretty clever.
Yeah, there's locks and locking. So locks is mutexes, locking was center fours.
Well, no, maybe it's not for
Does semaphores have that?
Yeah, so yours is, your exam's appropriately named. So yeah, this was just locking because I don't know. So you're given 4 threads that get properly created and run. There's a bunch of garbage here. Let's Oh,
Wait, wasn't this a
no, this was similar to the one we saw.
Oh,
So, in this case, so we have, I think by default, I just gave you initialize, gave you some functions, and then gave you all the comments for them.
those lines you crossed out, we're supposed to write them ourselves.
Yep,
No?
that was the solution. So,
Ah, okay. I didn't see none, so.
yeah, so we all forget them now. So we have an initialize. I said you can initialize your center force to whatever value you want. Huh? Oh, we're good?
Yeah,
Okay.
we're good.
All right. So we have 4 threads here. Thread 1 calls F1 and then F2. Thread 2 calls F3, and the comment says that this should run only after F1 completes. In thread 3, we have F4 that runs only after F1 completes. In thread 4, we have F5 that should only run after F2 completes, and then F6 that only runs after F3 and F4 complete. So, using semaphores, how would we make all of the comments true?
Okay, so we have 6 functions and okay, why is dependent? We have F1, F2. F6 is dependent on both F3 and F4.
So, when we have a semaphore question, we should first think to ourselves, well, what do we want to prevent from executing? So, in this, should I prevent thread 1 from executing at all?
No.
No, it's good. It can just go full bore. Should I prevent thread 2 from executing at all?
Yes.
Yes. So I should probably have a wait. So I'll just uncomment it. So I'll need a wait on some semaphore. So I'll just make one called sem1. So if I make one called sem1, next I should probably argue about its initial value. So what should its initial value be? 0, because I want it to not continue. So semaphore 1, I'll just write shorthand, gets an initial value of 0.
Is there like a semaphore, not library, but is there something that uses semaphores to like make it easier for a user to code and be like, oh, I just want threads like for these functions to go in this order, and then it's just like a semaphore library, like it just uses semaphores to do code.
Possibly, but your library would probably quickly get more complicated than actually just doing semaphores. So, next one, thread 3. Do I want to prevent thread 3 from executing?
Yes.
Yes. Oh, well, guess what? I want it to wait on F1, so it should be waiting on the same thing that that thread 2 is waiting on. So this should also probably wait on sem1, and current value is 0, so I prevent it from running. All right, thread 4 I need to prevent from running. So, should this be the same as sem1, or should it be a new semaphore?
It should be a new one, I guess.
New semaphore, I want to prevent it from running, so I will have a sem wait of sem2. And what should the initial value of sem2 probably be? 0, because I don't want to do anything. All right, so now we're at this point. So sem2 equals 0. So now let's tackle fixing thread 2 from executing. So thread 2 should only execute after F1 complete. So how do I make sure that thread 2 can actually call F3?
We
Yeah,
post it.
post after I'm done F1, right?
Yeah.
So post. All right, so if I just have one post there, is that good enough?
Like, well, we don't care about that too.
What? Well, isn't it good enough?
Nope.
Well, if we also care about
So
security,
if I only have one post, that would change the value from, from 0 to 1. And then, well, either thread 3 or thread 2 will execute next. Say this one goes and decrements it from 1 to 0, and then it runs F4, and now, oh, guess what? Thread 2 can't run.
Yeah, you can always like, we need to post it 2 times then.
Yeah, so
Post it within, like, if you wanted to specify further, like, if you wanted thread 2 to run before 3, you could just post within 2. But after F3, you can just post.
True.
after F3,
Like,
No,
so,
you don't know whether thread 2 or 3 will
no, but
find
thread 2,
the first.
no, well,
what?
one post.
You-
That one post then at
then
random.
I just-
So you want
No,
to,
no,
oops,
But that makes the
you want to move this
It
here?
makes the condition stronger. Huh?
You want to move this here?
No, I'm saying if you really wanted to, you could have it there. It wouldn't be a big problem unless you had. You're just further adding a restriction. Like now you're saying thread 2 has to run before thread 3.
Yeah, true. But anyways,
But
this is good enough.
I'm not saying thread 1 has to run before thread 3.
No. I'm saying if you put a post like after F3 line,
Yeah, well, that's what I just said. I said, what if I move this line here, essentially?
then essentially you made it so that thread 2 has to go for 3 as well. But that's not a restriction.
That's not at all.
Yeah.
Yeah.
That
you
ain't
have,
what
you have no
that ain't what
guarantee
we're
that thread 2 will actually be the one that unblocks from the wait.
It'll be the only one that can unblock, so it will unblock.
Why?
No, thread 3 could unblock too. Or thread 2.
It can unblock. Oh, I see. Yeah, there's some way there.
Yeah.
Both of them are wait resistant, and they can only post once. Then
Took that out and then.
You could have them both post if you want.
yeah,
It'd be,
what you
it'd be,
could do is
w-
move
weird.
the second post to after both of the waits.
All right, so,
That was the main thing, the end value of the semaphore 1, not 0.
but that doesn't matter really, right? All right, so now we got this check and this checks, right?
Yeah.
We're good for those? All right, let's tackle something else. So we have a wait for sem2. So that wants to run only after F2 completes. So can we fix that one?
We post sem2 after F2.
Post sem2 after F2. So post sem2 here. We all
I
agree.
believe that's what we should do.
We all agree with that? All right, that looks good. So then we have this check. All right, so the last condition we have is F6. We want to run it only after F3 completes and F4 completes. So how do we do that? Wait twice? So yeah, I should probably have a wait. Oops. I probably need a new center for, so sem3. And what should the initial value of sem3 be?
0.
Probably 0. So now in this case, I want to make sure that it runs only after F3 and F4 complete. So that probably means I need to post sem3 here and also post sem3 here, which creates a bit of a problem because right now, well, F6 could execute after F3 or F4 complete because I only have one wait. So in order to make sure both of them
So we wait
complete, I just wait twice. Oops. So now I can go ahead and give it the old check and then make sure that I'm not criminally insane. See, that was wait for sem3, post sem3, post sem3. All right, we're good, yay. Yeah.
I have a question. So, like, I was wondering, so what if, like, because like, thread 2 and 3, I execute after, like, F1 finishes, which means that, like, it could happen, like, so that, for example, F3, like, executes and increases semaphore by 1, and then, like, F6 executes and like, there's 2 waits.
Why does
Yeah, and the
F3
first wait just, like,
increase
turns to you and, oh, yeah, sorry. There's 2 waits for the
Yeah, yeah. For which one? Sem 3?
Can initial values be negative though?
Oh, initial values cannot be negative.
Ah.
Why not?
That is, how are they defined? The value is an unsigned int. Unsigned ints cannot be negative.
Do they overflow?
Yeah, you can just
It-
You could divide it as max int minus 1.
Well, then it would be,
That would be undefined negative.
depends on
Probably
how
rolls out.
big.
yeah. Well, max int would fit,
Yeah, I mean,
technically.
it's clean weight,
'Cause
so
max
yeah.
int would be,
But I think overflow is undefined. You're not guaranteed that going below or above the
What's the definition for sem weight again?
sem weight definition is that it will decrement, but if it cannot, if the current value is 0 and it would go negative, it will block until that another thread increments it, and it can actually decrement it and continue.
Oh, so it does not decrement it into negative y.
Nope,
No, it doesn't.
it cannot go negative. So if the current value is 0, it blocks until someone else increments it, so I can decrement it back down to 0 or some positive number.
There's no purpose if it could.
Yeah.
If it decrements back to negative y, then weight times it back to 0, right?
Yeah, cannot be negative 1. All right, so the next question was, for each function, state which functions could run in parallel, not including itself. Write none. So which functions can run in parallel with, let's say, f1?
No.
None of them can write in parallel with it, right? So they all wait for something else, so nothing else can run in parallel with f1. What about f2? What could run in parallel with f2?
F3 and F4.
Whoops,
We're talking about F1 and 2 or thread 1?
the f functions. So f3 could run at the same time as f2, so could f4. Could f5 run at the same time as f2? No, because it's waiting on it, right? So what about f3? So that should be able to run at the same time as f2. F4, and can it run at the same time as f5? Yeah.
Oh yeah.
Can it run at the same time as f6?
No.
No, because it's being waited for. All right, so what about f4? So f2 can run at the same time as it, and f3. Can f5 run at the same time?
I think so.
Yep. Can f6 run at the same time?
No.
Nope. All right, what about f5? So can that, yeah, commutative, so it should be run at the same time as f3, run as the same time as f4. Can it run as the same time as f6? Yeah.
Wait, what?
No, it can't immediately proceed to.
Yeah, no, it's running in a thread, so a thread has to run sequentially. It's a thread.
So there's no F6, right?
Yeah, so what can run in parallel with f6?
No one?
Not a.
Yeah.
All right, so let's see, is that good? A looks good.
Pretty good.
All right, so what question do we want to try and speed run 5 minutes?
Memory allocation.
Memory allocations, all right, probably good. You decide to use a buddy allocator to handle a bunch of fixed size allocations. It was too early and you slept through slab allocators. Yikes. So your allocator needs to be able to handle 8 allocations of 10 byte each. How big of a memory block does your buddy allocator need at minimum to be able to handle every allocation? Justify your answer. So,
16 bytes.
so yeah, for each allocation, well, if it wants 10 bytes, it needs to be a power of 2. So each of them is going to be 16 bytes. And if I have 8 allocations, well, I have 16 essentially times 8.
I'm a little fried right now, so if you,
So that is 128 total.
it's not any different if you do like 8 times 10 and that's 80 and that means you need 128 to the next round.
No.
I think you
You have different allocations. Each allocation has to be a power of 2.
mathematically, I think you could try and
So if it had a slab allocator, you could move them all right next to each other. That would be more efficient, but we have a buddy allocator. All right, so next question is how many bytes are lost due to fragmentation and what type of fragmentation is this? Justify your answer.
Internal and 8 bytes. Wait, 6 bytes times 8. Yeah.
Internal fragmentation, so for each of them, I'm losing 6 bytes because I get 16 and I only use 10 of that. So I am wasting 6 bytes per, and I have 8 allocations. So that equals whatever that equals. What's that equal? 48. So I have 48 bytes lost due to internal fragmentation. Yeah?
Wait, sir. Can
Yep.
you remind me what external fragmentation could be like?
External fragmentation is wasted space between, between blocks themselves. So in this case, I might be able to consider, with buddy allocators, typically you have way less internal fragmentation. But say I had like 8 16-byte ones, something like that, and then
The blank spaces between the blocks are the external fragmentation.
well, so right now we don't have any blank space between the blocks. We have 16. Something like that. And then say I went through and I freed some of the allocations. So let's say I freed this allocation, so now this one is free, and now this one is free. So in total I have 32 bytes free, but now if I have a 32 byte allocation, oh, I can't fit it anywhere because these free blocks are not contiguous. So that would be considered external fragmentation because I have wasted blocks essentially. All right, so anything else real quick?
How does the slab allocator work, by the way? Can we just quickly speedrun that?
Slab allocator works, do lab 6. Lab 6 is a slab allocator. Needs a bitmap, you do a bitmap in lab 6, and all the blocks are essentially a giant array of inodes. That's a slab allocator. I don't know. Yes. All right, with that, just remember, going for you. We're all in this together. You can outro.